Students, today we shall start with our chapter number 2, Polynomials. So first of all, I shall give you some definitions regarding polynomials. Let x be a variable and n be a positive integer and a0, a1, a2 and so on up to an be constants, that is real numbers. Then an into xn plus an minus 1 into x raised to n minus 1 plus an minus 2 into x raised to n minus 2 plus a1x plus a0 is known as a polynomial in variable x. Generally, we use the notations fx, gx, etc. to denote a polynomial in variable x. For example, 2x square minus 3x plus 4 is a polynomial in variable x. But 3x square minus 2 into root of x minus 4 is not a polynomial, as the exponent of x in 3 root x is not a positive integers. Now we come to terms and coefficients. We take a polynomial fx is equal to 2x square minus 7x plus 8. Here the terms are 2x square minus 7x and 8. So in this, the coefficient of x square is 2. The coefficient of x is minus 7 and 8 is known as constant term. Now come to degree of a polynomial. The exponent of the highest degree term in a polynomial is known as its degree. For example, fx is equal to 7x square minus 3x plus 5 is a polynomial of degree 2. Now come to few more definitions. We have constant polynomial. A polynomial of degree 0 is called a constant polynomial. For example, fx is equal to 2 or gx is equal to minus 5 and many more examples you can have. The constant polynomial 0 or fx is equal to 0 is called a 0 polynomial. The degree of the 0 polynomial is not defined. Now come to linear polynomial. A polynomial of degree 1 is called a linear polynomial. For example, fx is equal to x plus 5. In general, linear polynomial is written as fx is equal to ax plus b, where a is not equal to 0. Come to quadratic polynomial. A polynomial of degree 2 is called a quadratic polynomial. For example, fx is equal to 2x square minus 3x plus 7. In general, quadratic polynomial is written as fx is equal to ax square plus bx plus c. Here a is not equal to 0. Now come to cubic polynomial. A polynomial of degree 3 is called a cubic polynomial. For example, fx is equal to 7x cube plus 4x minus 12. In general, cubic polynomial is written as fx is equal to ax cube plus bx square plus cx plus d, and a is not equal to 0. Now come to biquadratic polynomial. A polynomial of degree 4 is called a biquadratic polynomial. For example, fx is equal to 10x to the power 4 minus 7x cube plus 5x square minus 12x plus 20. In general, biquadratic polynomial can be written as fx is equal to ax to the power 4 plus bx cube plus cx square plus dx plus e, and a is not equal to 0. Now come to our exercise number 2.1, which is a very simple exercise. For the first question, we have been asked as which of the following expressions are polynomials in one variable and which are not, and state reasons for your answers. So the first part is 4x square minus 3x plus 7. So it is a polynomial in one variable x, you can see. In the second part, y square plus root 2. Here also it is a polynomial in one variable y. 3 into root of t plus t into root 2. So it can be written as 3 into t to the power 1 by 2 plus root 2 into t. It is not a polynomial since here the power of the variable t is 1 upon 2, which is not a whole number. Now come to the fourth part, y plus 2 upon y. It can be written as y plus 2 into y to the power minus 1. It is not a polynomial. Here you can see y raised to the power minus 1. Minus 1 is not a whole number. Come to the fifth part, x to the power 10 plus y cube plus t to the power 50. You can see here there are three variables x, y and t. So it is a polynomial in three variables. Now coming to the second question, write the coefficients of x square in each of the following. To the first part, you can see 2 plus x square plus 1. Here you can see the coefficient of x square is plus 1. In the second part, the coefficient of x square is minus 1. In the third part, you can see the coefficient of x square is pi upon 2. And in the fourth part, you can see you don't have a coefficient of x square. That's why we write it as a coefficient of x square in this case is 0. Now coming to the third question, we have to give one example of a binomial of degree 35 and a monomial of degree 100. So a binomial of degree 35 is x to the power 35 minus of 4 and a monomial of degree 100 is y to the power 100. Now coming to the fourth question of the same exercise, we have to write the degree of the polynomials. In the first part you can see the highest power of the variable x is 3. So it is a degree or degree of polynomial is 3. In the second part, the highest degree power of the variable y is 2. So here the degree of polynomial is 2. In the third part, the variable t has highest power 1. So it is a degree polynomial of degree 1. And in the fourth part, 3 can be written as 3 into x to the power 0. So here the degree of polynomial is 0. Now coming to the fifth question, classify the following as linear, quadratic and cubic polynomials. You can see the first part, the highest power of the variable x is 2. So it is a quadratic polynomial. In the second part, the highest power of the variable x is 3. So it is a cubic polynomial. In the third part, the highest power of the variable y is 2. So it is a quadratic polynomial. In the fourth part, the highest power of variable x is 1. So it is a linear polynomial. In the fifth part, the variable t has highest power 1. So again it is a linear polynomial. In the sixth part, the highest power of the variable r is 2. So it is a quadratic polynomial. And in the last seventh part, you can see the highest power of the variable x is 3. So it is a cubic polynomial. Thank you so much.